Hello everyone, welcome to Rasayan Academy once again. So guys, this is another series of few important topics that we'll be discussing. Now I have named this series a short series, right? And we are going to discuss a lot of short tricks regarding a lot of different topics. For example, stereochemistry, organic reaction mechanism, all the short tricks which are helping the students in cracking most questions in the CSIR NET examination. So we are starting from the very basic one, that is finding the R and S nomenclature in the flying wedge and the Fischer projection. So this is like something very preliminary, and I think everyone should know this. If you are following these two or three short tricks, you are not going to get any of these questions wrong. So let's practice quickly. First one we are going to take in the flying wedge projection. So sometimes in the books it is shown to you that you must first convert the flying wedge into a Fisher projection and then find out the RNS nomenclature. However, you can do it directly as well. So what you have to do first of all is, first of all, guys, check the least priority group. Okay, so how are you going to give the priority based on the Khan in Gold Prelog rules? I just hope that you know the CIP rules. If not, I can make another video on this. So this is something very important as well as easy. Check the least priority group first and try to keep it below the plane. So when you are giving the numbering 1, 2, 3, 4 in the flying wedge conformation, right, flying wedge projection, least priority group should be kept below the plane. If somehow it is not drawn below the plane, you don't have to write it in a different way. What you are going to do is, whatever configuration you find out, if the least priority group is above, if the least priority group is above, you just have to invert the configuration. That means, let's try it out on this first molecule. So we will first give all the priority and let's check where is the least priority group. First priority, according to the CIP rule, the first rule says that you are going to give the priority based on the atomic uh, number, right? So oxygen has the highest atomic number. So we are going to look at the first atom which is connected to the chiral carbon. Okay, so first atom is oxygen, first priority. Second is to this group. Now, how do we know both of the carbons which are connected? Here also there is a carbon, here also there is a carbon, but here when we move onwards from this carbon, you will see only three hydrogens. In the case of ethyl, you will see two hydrogens and one carbon. So that's why second priority. Third and last, fourth priority to the hydrogen. So here you see once again, least priority group is the hydrogen group. Where is it? It is above the plane. So are we going to rotate and write it below the plane? No. We'll just see the rotation from 1, 2 and 3. The rotation is clockwise. If the rotation is clockwise and if you're having the least priority group above, what are you going to do? Clockwise rotation usually gives you R configuration. Yes or no? Clockwise rotation gives you R, but when the fourth priority group is above, you are going to write S. So this molecule will have S configuration. I just hope you understood that whatever is the rotation, write the configuration for it. If the least priority group is below, it will be as it is. If it is above, it will invert. Let's look over here. So once again, the priority 1, 2 and 3, 4. So what happens over here? Once again, 1, 2 and 3, it is anti-clockwise. Anti-clockwise motion gives you S, but the fourth group is once again above. So what are you going to do? You are going to write this is R configuration. Okay, so this is what you had to see in the flying wedge configuration. Now we will be seeing more examples based on these. You have four examples over here. You can stop the video and do it by yourself and then check it later. So for the first one, what we have is, for the first one, so when we are giving the priority order, we will see if there is a double bond, we are going to compare the atoms to which the double bond is. If the atoms are also same, then we are going to open up the pi bonds and check how many pi bonds are there. So very simply, in the first one, you will see that the carboxylic acid will have the first priority. Why? Because it is connected to oxygens through double or single bond, right? Then second will go to the phenyl group. Why? Because it is, even though there are double bond, but still it is connected to another carbon only, right? third priority to methyl, and fourth priority to hydrogen. You see the hydrogen once again it is above. So 1, 2 and 3 should have given you R because it is a clockwise rotation, but since the hydrogen is above the plane we are going to write S configuration. So 1, 2, 3 clockwise, but hydrogen above, so S configuration. Now here in option number 2, you have two chiral centers over here. So take care of this. There is one in one of these the hydrogen is above, in the other one hydrogen is below. So let's find out for this carbon first. So yes, first priority as always will go to the atom, to the heteroatom directly connected. So to this carbon an oxygen is connected, to this carbon a phenyl group is connected, as well as a carbon connected to NME2. So where is the second priority going to go? Second priority will go to this carbon Y, because here it is connected to an heteroatom nitrogen and a carbon. So first point of difference we are going to find out. Don't see how many groups it is connected, only see if it is connected to a group having a higher atomic number. So second priority, and over here third priority. So 1, 2 and 3, this goes anti-clockwise, should have been S, but once again the fourth priority group is above. So you're going to write this carbon will be R. What about the second one? Let's see as well. NME2 and a methyl group. So in the second one you see that there is a hydrogen below. So a nitrogen will have the first priority. Similarly, the second priority goes to this carbon connected to oxygen. Third priority to the methyl group, and fourth priority to hydrogen. So here whatever your rotation you get, it will be as it is. 1, 2 and 3 you get anti-clockwise, so that's going to give you S. Why? Because the least priority group is below the plane. So your molecule over here would have R and S configuration respectively of this and this carbon. Similarly, you want to try the same out with option number 3 over here. So here you have a cyclic molecule with a chiral center like this. So apart from everything else, you know the least priority group is below the plane, right? You have spotted that out already. So who gets the first priority? Nitrogen will get the first priority because this carbon directly connected to nitrogen. Then it is connected to an oxygen but through a CH2 group. So this will get second priority, third priority over here, and fourth. So 1, 2 and 3, as you can see, 1, 2 and 3. So when you count 1 through 2 and 3, you don't see the 4 in between, right? So 1, 2, 3 is anti-clockwise. It will be S as it is because the hydrogen is still below. So I just hope you get the point. Last one in the flying wedge. So here you are going to have first priority of the OH group, second priority for the carbon of the alkene, third priority to the methyl, and fourth priority over here to the hydrogen. So 1, 2 and 3 is going to be clockwise in nature. Hydrogen is already below the plane, so it's going to be R configuration. So guys, I have given you already, I have made two videos on practice questions of stereochemistry. I'll put up the link of these two videos right over here. Okay, and you can check them out. A lot of examples, very good examples are there. Now we move onwards to Fischer projection. And yes, before moving onwards, I would once again remind you to like, share, and subscribe to the channel. And please share if you think the content is good and is going to help your classmates also in cracking the exam. So, all right, so yeah, let's talk about the Fischer projection. Once again, what you have to do is in the Fischer projection, you just have to take care of where is your least priority group once again. So, priority order once again from the CIP rules. If the least priority group is on the vertical position, and if the rotation is clockwise rotation, it is going to be an R. So, basically, vertical, clockwise, and R. This is what you are going to follow. Just one, sequence V, C, and R. Now, the second thing what you can do is you can change only two variables out of this. For example, if it is not on vertical, it's on horizontal position. And if the rotation is still clockwise, you are going to get S. So as I said, you can change only two variables. from here. Okay. Similarly, if it is on the horizontal position and you have anti-clockwise rotation, it will still be R because you can only change two variables with respect to this formula. If you have vertical and if you have anti-clockwise, it will be S. So two variables once again from the major main formula that we have. So just remember this one and just remember you can change only two variables. So let's try this out on this molecule over here. First thing, give the priority with respect to CIP rules. So the amine group is going to get the first priority, second for the carboxylic acid, third for the isopropyl, and fourth for the hydrogen. 1, 2 and 3 it's going to be clockwise, and yeah, we see V and vertical position, and we see clockwise, and we see R. This is going to be a R configuration molecule. Similarly, now we have two chiral carbons over here. Let's try this out on the first one over here. So now giving the priority could be a little bit tricky. Also look at the second carbon chain. So what we are going to do is first priority to OH, second priority you can give to pH, or you can give the second priority to a carbon connected to oxygen over here. So second priority to the second carbon, third priority to pH, and fourth to the hydrogen. You see 1, 2, 3 is clockwise in nature, but it is on the horizontal position. So what did I tell you? Horizontal and clockwise is going to be S. So the first carbon is S configuration. We find out the same thing for, let's say, the second carbon. All right, drawing it once again for clarity. So yes, first priority to the aldehyde group. Second priority would be to this upper carbon because it is connected to oxygen. Third priority to the ethyl. Fourth priority to methyl. So once again, 1, 2, 3 is clockwise, but you have the group on the horizontal position. So it's the same thing, horizontal, clockwise, and S. Both of these carbons will have S configuration in the first one. Hope it makes sense. Let's try the same thing on the second molecule. So once again, quickly giving the priority order 1 for the OH, second priority order to the second carbon, third to this methyl, fourth. So 1, 2 and 3 is clockwise and horizontal. Horizontal clockwise is going to give you S configuration. Now for the second one, I'm just drawing over here only 1, 2 for this carbon, 3 and 4. So it is 1, 2 and 3 clockwise and horizontal position. So let me just see this once again. 1, 2 for the second carbon, 3 and fourth, right? All right, horizontal clockwise and S. What about the second one? 1, 2, 3 clockwise and horizontal S once again. Okay. About the third one, 1, the second, the priority order. Over here you have to check with respect to this carbon, with respect to this carbon. So this carbon, if you open this up, it has formed three bonds with nitrogen. This carbon has formed one bond with nitrogen, another with carbon, another with carbon. So second priority to the cyanide itself, third priority to this carbon, and fourth to CH3. So you see it on the vertical position. It's vertical and clockwise. 1, 2, 3 is clockwise. So this is going to be R. Okay. Similarly, you look at the last carbon, amine, COOH. All right, there is a methyl over here. So once again, 1, second priority would be to the cyanide, or sorry, second priority could go to the carboxylic acid, third priority would go to the cyanide, and the fourth priority would go to this whole group. Okay, so we see 1, 2 and 3 is anti-clockwise and we have 4, so this is going to be S. All right, 1, 2, 3 anti-clockwise and on the vertical position, so vertical anti-clockwise is still S. Last one, greater atomic number. Bromine is the one having greater atomic number. Then comes chlorine. Then comes the carbon connected to oxygen. And then finally comes the methyl to the fourth priority group. So 1, 2, and 3 is going to be anti-clockwise. Vertical anti-clockwise is going to be S. All right, once again, the last one, let's draw it over here. C2H5, and the above carbon remains the same, Cl and Br and methyl. So first priority, as always, to the OH group. Second priority would go to this carbon connected to two heteroatoms. Third priority to the ethyl, and fourth to the hydrogen. Where is hydrogen? On the horizontal position. So 1, 2, and 3 is clockwise. Horizontal clockwise is S. So this is also going to be a S configuration. All right, so these are all very simple tricks which you can apply on most of the molecules and get it right on all the molecules basically. And if you're liking this video, please share it. I have already pasted the link over here. You can just visit more practice questions on stereochemistry. And yes, more short trick videos like this are going to come up very, very soon.